Thank you so much for joining this lesson. You are all invited to Shifting Grades Online School. And if this is your first time to partner with us, we kindly request you to subscribe and also to invite your friends to Shifting Grades Online School. This is the home of academics. We are still handling the color trial examination. When we talk about color, we mean a joint exam done by the Kenya High, Alliance High, Lenana School, and Alliance Girls High School. So we are on the paper one. Section one has already been done. So you will allow me go to the section two of this paper directly to the section two. And please note that we have very serious programs. Every holiday, April, August, November, December, we usually have very engaging classes for all the continuing students and all the candidates. Remember to reach out using the number 070415 3366. That's my line. You can reach out anytime for consultations. Remember, for December, we are involving senior school, junior school, and upper primary. That one should be very specific. Upper primary school. Yeah. For the lower primary, we may think about it with time. So for now, please enroll your brother, your sister, your son, your daughter, your sibling, your nephew, your niece, your friends who are in upper primary and above. Be reminded also, the candidates, that we have very engaging programs starting on the second week of term 3 and every term 2 and term 1, every Wednesday, Friday, and Sunday for the candidates. KCSE candidates Wednesday, KCSE candidates again Friday, and KCSE candidates for mathematics every Sunday in the evening, that is 7:30 p.m. So please use the same number which has already been typed here on the poster so that you may get a slot in our programs. Very good classes. Now, at number 17, a technical and vocational education and training, that is a TVET, planned to equip computer lab by buying some computers from a total of 2,625,000 Kenya shillings. Due to inflation, before they could buy the computers, the price per unit was increased by 2,500 Kenya shillings. Now, this increase in price enabled the institution to buy 5 less computers using the same amount of money on original plant. Taking X to be the original number of computers, part A, write an expression in terms of X representing Roman 1, original price per computer. When you talk about original price per computer, it means we take the total amount of money which is going to be used by this particular institution, this particular TVET, 625,000, and to divide by the original number of computers. Original number of computers that were to be bought. So this now is the original price per computer according to the expression by X. Then again in Roman 2, new price per computer. When you talk about new price per computer, it's good for you to remember that they are going to buy a new number of computers. So the new number of computers, new number is X minus 5, because this enabled them to purchase 5 less computers. Therefore, using the same amount of money, but now we are purchasing 5 less. So the computers now are X minus 5. That's the meaning of 5 less computers. That's Roman 1 and 2. Can we check part B of the same question? Now, form an equation using the expressions in A above and hence determine the number of computers the school bought. Number of computers the school bought. In other words, determine the new number of computers. Determine this value. So now we're going to say this. This new value or the new price per computer is greater than the original. You understand that? 2,625 thousandths out of x minus 5. When we subtract the original amount that would have been used for a computer, when you subtract the original amount that would have been used for a computer that's over x, we're supposed to get the differences 2500. Is that so? Can confirm. 2500, it's here. We should get 2500. So this is now, if it's of course over 1. So this is now the equation that we're supposed to solve so that we get the value of x and hence the number of computers that the school actually bought. Now from this, we can talk about LCM of the denominators. So this is x, remember that. So we are now talking about LCM divided by the first denominator. X minus 5 shall cancel. Then we will have x remaining. So 2,625 thousandths times x minus LCM divided by the denominator in the second case. It's x to cancel. So we remain with 2,625 thousandths into x minus 5. And this is equal to LCM divided by 1. It remains the way it is. So 2500 times the LCM, x squared minus 5x. You get that? We can do away with the LCM. We expand by opening the brackets. Then we group terms together and we proceed. So 2,625 thousandths x minus 2,625 thousandths x. Then this now becomes positive because it's a negative 2 point and a negative 5. Let me multiply that. 2,625 thousandths by 5. Now this is giving me 13,125 thousandths equals to 25 x squared minus 2500 by 5. This is giving me 12,500x. Can we group terms together that are similar, of course? This and this shall cancel. It's 0, 0. You get a 0. The same, okay, 6.25 million x minus the same value of x. So that becomes 0. Now we're having 25. We're having 25 x squared minus 12,500x. Then this now will be minus when it goes to the side with those other components. 13,125 thousandths. And we remain with a 0. We can make it simpler by dividing by 2500 throughout. So the value of x squared minus this value divided by 2500, we're getting exactly 5x minus, when you take 13,125 thousandths and we divide by 12,2500, I'm getting 5250 equals to 0. So this is now the equation in its simplest form that we're supposed to solve for us to get the value of x or the values of x. You get that? The values of x. So now we need to talk about the value of x using what we call the quadratic formula. X will be given by negative b, which is negative 5, plus or minus the square root of b squared, which is a negative 5 that we are going to square. Negative 5 squared minus 4, the value of a, which is 1, the value of c, which is negative 5250. Then out of 2a, 2 times the value of a. So 2 times 1, yeah, like that. All right. Can we take our next value to this point up here? This is 5. When you take negative 5 by negative 5, negative 5, it becomes 5 plus or minus. Let me now get my calculator 25 minus 4 into. Minus, that's a negative. So we will get positive. We are having negative 4 and negative 5250. So they change to positive. So 25, now we are adding 4 multiplied by 5250. I'm getting 21,025. Then I take the square root, plus or minus 145 out of 2. Now the values of x shall either be 5 plus 150 over 2. I'm getting exactly 75, or x equals to 5 minus 145. Then we divide by 2, or negative 70. Now that it is a number of computers, then we settle for x equals to 75. It's supposed to be a positive value. So the number of computers that were to originally be bought, which is the value of x, is 75. Now we are forming an equation, hence determine the number of computers the school bought. So the school bought the number that was bought, 5 less. We want the new number that was actually bought. So exactly 70 computers were bought. Exactly 70. That is the number of computers that were bought. A good question. Very, very good. If you're learning something, type yes. Yes, I'm learning. On the comment sections, type yes, I'm learning. Now, can we go together to part C? Calculate the percentage increase in the price per unit of the computer bought, correct to 4 significant figures. So can we get original price per computer? 2,625. We were to purchase 75 originally. So 2,625,000 out of 75 computers, 35,000. New price per computer. Instead of dividing this by 70 computers that were actually bought, that's what I will do. Instead of that division, remember, you can still add. You can still add 2,500 to 35,000, and you will get the same new price. You can add this one directly instead of the second division. Now, percentage increase, or can we get the increase first? Increase shall be, actually we know the increase. We are overworking. We didn't need this value, guys. We didn't need the second value, though it's good. Anyway, now that we have overworked, let's continue overworking. You see, this is now 2,500. My point was the increase is already known. So according to the information, so what we needed was just the original price. So that percentage increase will be given by the increase out of original. Now this should be expressed as a percentage. So let me work out 2,500 by 100 out of 3,500. I'm getting 7.143. 4 significant figures, 7.143%. Yeah, that is now the change expressed as a percentage. The change in price, or the increase in price, as a percentage. That's a very good question, ladies and gentlemen. Very, very good. So together we can check number 18. Now in number 18, this is what the examiner says, that every month a forest ranger drives a distance of 70 kilometers on a bearing of 0.68 from the forest headquarters to pick up another ranger at station A before proceeding for a joint patrol. The forest observation post is 85 kilometers from station A on a bearing of 35 degrees from south towards east. Now, after completing the patrol, they travel a distance of 95 kilometers on a bearing of 255 to inspect a water point used by wildlife before the forest ranger drives back to station A to drop off the other ranger and then return to the forest headquarters. Look at that. Part A, using a scale of 1:1,000,000, represent the information on a scale drawing. According to the scale, 1 centimeter represents 1,000,000 centimeters. Now, 1 centimeter represents, the centimeters being represented can be converted to kilometers by being divided by 100,000. So when you divide by 100,000, you get 10 kilometers. So 1 centimeter will represent 10 kilometers. We have a compass here to guide you, and I hope it's our original point. So we can start our construction from this point. So our reference point shall be what? You see, a forest ranger drives a distance of 70 kilometers on a bearing of 0.68 from the forest headquarters. So assuming this is the headquarters, the HQ, to pick up another ranger at station A. Okay, where is station A? 70 on a bearing of 0.68. So from the north, we measure 68 because that's true bearing. From the north, we are measuring 68. We measure 68 points there. 68. Then we produce a straight line. A very, very straight line. Now with that straight line, agree with me that now we need to measure only 7 centimeters instead of 70 kilometers. 7 centimeters. So doing 7 centimeters will bring me to this point. 7 centimeters like that. That becomes our station A. Then we continue interpreting the information. After locating position A, which is 7 centimeters from the headquarters, we're supposed to raise a very vertical compass at that point. Very vertical like that. So that it's parallel to the first one. Then we continue interpreting the instructions. Now, the forest observation post is 85. Taweka vizuri. So you see, 85 from station A on a bearing of 35 from the south towards the east. Look at that bearing. This is now compass bearing. So from the south, 35 and towards east. From the south, I measure 35. I measure what? 35. I measure 35. Then I'm moving to the east. Like that. So I've measured. Yeah, let me prolong this one. So this is going to be 35. From south towards east. That is the meaning of compass bearing. The distance is supposed to be 85 kilometers. According to the scale, it will now be 8.5. 8.5. You see that? 8.5. 8.5. 8.5. So let me measure 8.5. A distance of 8.5 shall be at this point. So that point will be what? We talked about the forest observation post. So the forest, call it F. Then we raise another compass at that position. Another compass at that position. Very perpendicular. So that it's parallel to the first and the second. 8.5. You've seen me measuring 8.5 centimeters. After that, what else? Now, after completing the patrol, they travel a distance of 95 on a bearing of 255 to inspect our water points. 255 to inspect our water point. Remember, to measure 255, we're already having 180. So how much are we adding to get 255 when there is already an automatic 180? We only add 75 to 180. We add 75 to 180. Remember, protractor can only measure 180 maximum. So when you add 75, then you'll get your 255. So I'm reading 75 at this position. Then I produce like that. Yeah, I produce. Let me do the line. Like that. So I've just added 75 here. So that when I add 75 to the automatic 180, then the bearing now becomes 255. And what distance is there? 95, meaning 9.5 centimeters. 9.5 centimeters. Let me check that. 9.5 centimeters shall be at a point like this. 9.5 centimeters. Then we raise very perpendicular compass there to the others like that. So this is now the water points. That is the water point. Now let's read the instructions again because there's something I want you to understand. Even if we can join this, I want us to read the information of what this patrol is doing here. Like that. So can we check? We are already having the diagram there, but now reading the instructions after completing the patrol, they travel a distance of to inspect a water point used by wildlife before the forest ranger does what? Drives back to station A. So they will get back to station A. Back to station A to drop off the other ranger and then return to the forest headquarters. So it's like they will follow the journey back once again. Let's read. We can now read the question. Now, using the scale drawing above, determine the part 1, the bearing of the forest headquarters from the water point. Forest headquarters from the water point. You see water point is at this point. This is the water point. So you need headquarters from the water point. So we have to be very careful there. We can just measure the smaller angle. Water point is the reference point. And I'm getting an angle of exactly 20. This angle here is exactly 20. So that angle can be measured as from the north, 20 degrees, turning to the west, so that you may connect headquarters from the water point. Alternatively, that's an angle of 340 when you measure it from the north and in the clockwise direction. You get that? From the north and in the clockwise direction. We can check part 2 of the same. Now, in part 2, we're being told that the bearing of the station A from the water points. Station A from the water points. Can we connect the two? Station A from the water points. We can first connect the two. Remember, we are interested on the distance. What we need is the distance there. No, it's the bearing. So bearing of station A from the water point. So from water point, again, it's becoming our reference point. So this now shall be, look at this. The angle is exactly 24 degrees here. 24. So how can we write that? Either a bearing of 0.24 for it to be true bearing, or from the north, an angle of 24 towards the east, compass bearing. So we can give either true or compass bearing. You see that point? Okay. Now, from there, we can continue interpreting the Roman 2, the distance between station A and the water points. Station A and water point. So this distance can be measured first in centimeters, then we convert to the SI units. I'm getting exactly, the distance is exactly, this distance is exactly 11.8. 11.8. Remember, thickness of your pencil may affect accuracy. So 11.8, we multiply by the scale so that we get an actual distance now in kilometers. 118 kilometers. 118 kilometers. We can check now part 4 of the question. We determine the total distance traveled by the forest ranger during the patrol. Forest ranger during the patrol. What are they doing? You can read. Every month, a forest ranger, okay, covers 70. On a bearing of 0.68 to pick another ranger, station A. So that's 70. Then we are told that the forest observation post is 85 from station A on a bearing of, so 85 is again being covered. After completing the patrol, they travel a distance of 95. Another distance of 95. Okay. Then now after that, what are we being told? To inspect a water point used by before. This is what you should take serious because that first distance is known. So before the forest ranger drives back to station A, so they are not passing through the what? In the return journey, they are not passing in the forest now. From the water point, they are going directly to A. So they shall use the 111 now. He's going to use the 111, 118, that is. Then, after using the 118, he is going to A to drop off the other ranger and then returns to the forest headquarters, covering the initial 70. Covering the initial 70. So this is now the total distance from headquarters to point A, from A to the forest to inspect wildlife, something there, from the forest to water, the water point. Now, from the water point, they go directly to A, so that the other ranger is dropped. So they are not going back to F, to the forest. They are going to A, the station, and back to H. So this is now the total distance, and I'm using kilometers so that they get the distance on the ground. Ground 70 plus 85 plus 95 plus 118 plus 70 once more. So I'm getting 438 kilometers. 438 kilometers is the total distance covered. Total distance that is covered. A good question in number 18. You learned something? Type yes, I'm learning. This is Shifting Grades Online School, the home of academics. Please remember to be a subscribed member of this platform. We treasure you. It's good for you to know that we are already beyond, we are beyond 91, actually 99,000 subscribers. That's by the time I'm posting this video. We are already beyond 99,000. So we are less 1,000 or some few hundreds to the Silver Creator Award, which is awarded at the first 100,000 subscribers. We really need your support in this, and we value all our followers. So please do not be left out. Checking number 19 with you together to number 19. Want us to read the question together, understand the information and also the diagram together. If we are together so far, Type yes, I'm learning. Then we check this question together. Now, the figure below represents a flower pot made of concrete in the shape of a hollow frustum whose vertical height is 50 centimeters. You can see the diagram. Given that the top and the bottom radii 21 centimeters, 10.5 respectively, and width, a uniform width, thickness 4.2. There is a thickness there, which is uniform, 4.2 centimeters. Now, the question is here. The flower pot is also mounted on a solid cylindrical base whose height is 20, no 30, sorry. Calculate part at the volume of the frustum part. Volume of the frustum part, okay, of the flower pot in cubic centimeters. Now, one thing that I want you to know is that we shall apply what you call similarities and enlargements such that can extend this one this way, this one this way. It's becoming very long, but we have two. We have two. Okay. Now, we can now project the original cone from which this frustum was obtained. If we can do that, then we can relate and say, if this original cone was having a height equal to smaller h plus the height that remained, because we can talk of radii, the ratios of the radii. We being told that our bottom radii 21, and we also told that the top one is 10.5. So can we talk of 21, which is the radius of the original cone, out of radius of the smaller cone that was cut off? Since those are linear measurements, they should also give us the same ratio as the heights. So 50 plus the h that was cut. 50 plus h, that's height of the original, over height of the smaller. So cross multiplication will take us to 21h equals to 10.5 by 50, 525 plus 10.5h. When you subtract 21 and 10.5, are you getting the same value? 10.5h equals to 525. To remain with h, 525 divided by 10.5. I'm getting exactly 50 centimeters. Meaning that original h, look at this. Original h, according to similarities and enlargements, shall be 50 plus 50. Which is exactly 100. Yeah, which is exactly 100. Now, with this knowledge, we can proceed to formula. Remember, the formula for volume equals to original cone, a third pi, r squared h, minus the smaller cone that was cut off, like that, minus, subtract the 2. So allow me to talk about, there's something else I want you to observe again, that there is volume of the outer. You know the outer container. This is a flower pot. The outer volume, when you subtract the hollow part, we're going to get the volume of the material that will remain here, the volume there. So we need original volume, which will be given by, actually we need original volume, and we subtract another volume now, which will require the same formula. So for the original, we are talking about radius. Original radius, the outer radius, is supposed to be 21 plus 4.2. You know, when you add this, you're getting 21 plus 4.2 I'm getting 25.2. Then radius, the inner radius is known. The inner radius is known. So now I'm supposed to talk about a third. Pi. Did they give us a pi? Not really. So allow me use 22/7 r 25.2 squared times the vertical height. Vertical height is 100. Then I will subtract. I will subtract for the smaller cone that was cut off. Smaller cone that was cut off will have r as equal to 10.5 plus the same thickness here, which is 4.2. So 14.7. 14.7. So a third, let me record it here. I'm having a third pi r 14.7. This one I'm supposed to square. Then after squaring, I multiply by. After squaring, I multiply by the vertical height, which is 50. Now look at those measurements now. I'm using the external measurements of this particular frustum. So I've used the original cone and the smaller cone. A third, 22/7 multiplied by 25.2. Then I square that. Then I multiply by 100. I'm getting 66. 528 minus a third multiplied by 22/7 multiplied by 14.7 squared. Then I multiply by 50. I'm getting 11,319. So this shall exactly be 66, 528. I subtract, and this will give me 55,209. So this is now volume. This is volume of the outer frustum. What about the inner frustum? Inner frustum, or the space now, the hollow space. A third pi radius squared, a vertical height, minus a third pi radius squared, vertical height. So I'm subtracting these two now. A third pi r is 21. Then I square that and I multiply by 100. I'm getting exactly 46,200, and I will subtract a third by pi times 10.5 squared multiplied by 50. Okay, 5775. So the inner space in this particular container, 46,200, I subtract these ones, and I'm getting 40 and 425 cubic centimeters. Cubic centimeters. Now with those two volumes, outer and inner, we can now subtract them. We can now subtract the two so that you get the volume of the material that now remained. I don't know whether we are together now. That 55,209 minus 40 for 25. So 55,209, and I subtract, I'm getting 14,784 cubic centimeters. So now we are having volume of the frustum part. Volume of the frustum part. I had to take outer volume minus inner volume so that I get the material that's making this particular solid, which is a first term in nature. Part 2 of the same good question. Part 2 of the same question. The volume of the solid base. Solid base is cylindrical, so we need uniform cross-section times vertical height. Yeah, uniform section times vertical height. So in this one now, we shall need the outer. Remember, the base is not hollow. It's just holding a hollow frustum, but itself, it's not hollow. So it's 10.5 plus 4.2, which is 14.7. It's our radius. So we need pi r squared times its own height, which is 30. So 22 over 7 multiplied by 14.7 squared multiplied by 30. This is giving us 20,374.2 cubic centimeters. Yeah, that's a solid. It's not hollow itself. Only that. It is not hollow itself. It's supporting a hollow. Supporting a hollow frustum. But the base itself is not hollow. It's a pure solid. Yeah, part B. The same question. Now, the flower pot is to be painted on the external part only, leaving out the hollow frustum and the part of the cylindrical base resting on the floor. Part of the cylindrical base resting on the floor. So you see that? I hope you can see that now. And I want us to analyze very well. Find the total surface area that is to be painted to the nearest cubic centimeter. So in this question, we have to identify the faces very well that are to be painted. The part that to be painted is, we have the curved, outer curved, then the inner curved as a surface, then the top ring here, this ring here, it's also supposed to be painted. And then the base, the inner circle here, is supposed to be painted. Then from there, the outer is also going to be painted. So curved for the cylinder. Which part is not going to be painted? Leaving out the hollow frustum. Leaving out the hollow, okay, frustum, and the part of the cylindrical base resting on the floor. So the hollow part is not going to be painted. We shall only paint the outer. So the outer, look at this, the outer for the frustum, the top ring, and also the curved. The curved will also be painted. It will also be painted. So can we talk about top ring, which is circular? So we need pi r, the radius there, since it's circular. So we'll talk about a radius which is 25.2. 25.2. We square minus pi, a radius of the inner part, which is exactly 21. I'm on the ring. And this is also going to be squared. So this now will give us the top ring surface. Top ring, 22 over 7 multiplied by 25.2 squared. I'm getting 1995.84 minus 22 over 7 multiplied by 21 squared. This is 1386. So now The top surface shall be 1995.84 minus 1386. I'm getting 609.84. That's the top ring, there. What about the outer curved? The outer curved. You know it's cylindrical. No, it's what you call frustum. So the original cone minus the smaller. Original cone minus small. So can we get slanting height? Slanting height, we have a capital L, which will be given by. Slanting height of the original shall be, we have a right angle here. So this is 25.2, and the vertical is 100. Pythagoras theorem. So 25.2 squared minus, no, plus 100 also squared, and we take square root. 25.2 squared plus 100 squared. Then we take square root. This is 103.13. 103.13. What about L? Small l. We divide by 2 because of the scale factor that has been used. 51.6. No, 0.56. So centimeters. So now we need to talk about the curved. We need pi r squared, no, pi rl minus pi rl small. Pi rl is the curved of a cone. So pi r l, which is now 103.13 minus pi r, small letter r. Small letter r is going to be for the smaller 10.5. Yeah, we use 10.5. Smaller slanting height, 51.56. So we can compute these again. 22/7 times 25.2 times 103.3. This is giving us 8167.896 minus 22/7 multiplied by 10.5 multiplied by 51.56. This is giving us 1701.48. So 8167.896 minus, this is giving me 6466.416 centimeters squared. You see that? Centimeters squared. We were taught the nearest cubic centimeter, so I'm very keen to that instruction. When we'll be adding up, we shall consider that accuracy. We also need to talk about the curved surface here. The curved surface of a cylinder. The curved surface of a cylinder, and we use the outer measurement. The outer measurement will be 14.7. 14.7, the outer radius, 14.7. So 2 pi r h. 2 pi r h. Cylinder. 2 pi r h. 2 pi r times h. That 2 pi r h. 2 pi, a radius of 14.7 times the height of 30. I'm getting 2772 to 772. So from this, we can now get the total surface area 2772 plus 6466.416 plus once again 609.84. 609.84. So I'm adding now 6466.416 plus 609.84. This is exactly 9848.256 to the nearest 9848 square centimeters. That is to the nearest whole number. To the nearest whole number according to the instructions. That's a very good question. You have to think and think until you come up with the right analysis of a question like this. If we are together, type yes, I'm learning. Type yes, I'm learning. You're supposed to read instructions very carefully for you to be on the right side. You can't just solve out questions. You also don't have to work out questions as though you are working out a question that you saw somewhere. No, you treat every question with the uniqueness that it deserves. Every question should be given the uniqueness that it deserves. Number 20. We're moving. We are really moving. We are really moving. Number 20. Now, a county education office conducted a survey on learners' enrollment in 40 public junior secondary schools. The number of learners enrolled in each junior school was recorded as follows. So you can see the number. This looks like Nairobi County. Look at part A. Complete the frequency distribution table below for the data. Then part 2, on the grid provided, draw a histogram to represent the data. Now there's a lot that should be done in this. One, we're supposed to ensure something that is called a tallying column. A tallying column. So I will introduce here. A tallying column will not have any marks, but a tallying column will ensure that your accuracy on the distribution of values to their respective classes. So allow me introduce a tallying column at that point, so that when I start tallying now, I will be canceling a point. Look at this. If I cancel a value like 118, then I get to the class where 118 belongs, and I put a tick to represent a tick there. 248, 248 shall be here. 338, 338 shall be here. What about 425? Shall be here. What about a value like 526? 526 shall be here. What about 145? Back to this. 255 here. 349 here. 439, this one. 548 here. What about 167? Back to the first one. What about 267? 267 here. 355, this class. 447 here. 563. 563 there. 182, this class. 279. 279 here. 367. 367 shall be in this class. 458. This class. 589. This one. What about 195? 195, the first class, and they are already 4. So you wrap them, the fifth one, like that. 285. 285 shall be here. They are already 4. So you wrap like that. 378. 378, they are already 4. You wrap like that. What about 469? 469, they are already 4. So you wrap like that. 612. 612, they are already 5. You wrap like that. Are we continuing? 203. 203 shall be here. What about 298? 298, the same class. 389 here. 482 here. 645, this class. 219, 219, this class. 312, 312, this class. 402, this is the class. 495, this is the class. 720, this one. 237, 237, this is the class. After 237, 326, 326, this is the class. Okay. Then we are having 418, 418 here. What about 512? This one. Then, I'm sorry. 835, the last class. I don't know whether I put the stick for 512. I will confirm from the totals. These are 5. These are 5 plus 4. These are 5 plus 3. These are 5 plus 4. These are 5 plus 2. These are exactly 2. Can we confirm the totals? Can we confirm the totals? 5 plus 9, 14, plus 8, 22, 22 plus 9, 31, 31 plus 7, 31 plus 7, 38, plus 2, 40. They were 40 schools. So every value has properly been placed in its or on its respective class. That's a good one. A good one. If you're learning something more so on the preparation of the frequency distribution table, type yes, I'm learning. Type yes, I'm learning. Then part B of the same. Excuse. Now on the grid provided, draw a histogram to represent the data above. When you talk about histogram, more so when classes are not equal in length, like this one, classes are not equal in width. From 100 to 199, that's an interval of 100. 200 to 299, 100. 300 to 399, 100. 400 to 499, 100. 500 to 699. That's a very different range. 700 to 849, a very different range. So class widths are not the same. And for that reason, we introduce frequency density, which is given by each frequency over the class width. Frequency over the width. So we start with a frequency of 5 and a width of 100. The first class, 0.05. So here, if I'm to extend the table to accommodate frequency densities, here, then we shall start with 0.05. That's why they have chosen the scale in advance. Then this is another 100, so 0.09. All right, 8 will be divided by 100. 9 will be divided by 100. This is a trick. Some people may consider the first 3 classes, then they start thinking, the class intervals are uniform. Then they start applying. Maybe frequencies against class intervals, which will be very wrong. 7 will be divided by 200 because I'm considering 699.5 minus 499.5. That's exactly 200. So 7 divided by 200 is 0.035. Then can we check 2 will be divided by what? From 849.5 as the upper limit, divided by 7, okay, 699.5. I'm getting exactly 150. So 2 divided by 150. This shall give us 0.013. Like that, 0.013. So the first class is ranging from 99.5 as the lower limit to the upper limit of 199.5. And the height shall be the frequency density of 0.5. 0.5. So let me put the frequency density there. Then the class is moving up to this point. Yeah. The second one up to 0.09 and 299. 299 this way. That is now the second class. The other one has the same width, but the height is 0.8 according to the frequency density. The same width, but up to 0.8. That is the bar. The next one shall be from 400 up to 499, height 0.09. So same class width, the same class width. Then we anchor the class there and support it on the top. On the top. Yes, like that. From there, we talk about now 699 points. 699 points. So a bigger width. Then the height is 0.035. 0.035 at the mid. 0.035 should be at the mid. This way. Like that. See? And finally, 0.13. And it's up to 849. Yeah, 849. So 849 should be exactly at the mid here. You can check the average of 899.5 and 799.5. Yeah, 140. 849.5 should be exactly at this point. The height 0.013. 0.01. Then 3 should be after 2 just before 0.4. At that point, then you draw the line like that. So that is now what we are calling a histogram when class intervals are not the same. On the vertical axis, you draw frequency density. On the horizontal, what you call class boundaries. Class boundaries like that. That's what you're supposed to do. That's what you are supposed to do. Can we read now more questions on the same part C of the same question? Looking at part C of the same question. Use the histogram to estimate the median number of learners. Remember total numbers, the median number of learners. You see, the schools are 40. So we need 40 over 2. We get the 20th school. The 20th school will have the median number. The school at the middle, which is 40 over 2, that's 20, will have the number of students that are the median value according to the statistics. Therefore, at that point, you will allow me remind you that for us to get the frequency, you remember this, frequency density is given by frequency out of class width. Therefore, to get back our frequencies, then we shall need the frequency density multiplied by width. Therefore, every area, in other words, this is area of the bars. So the area of every bar in this particular histogram will give us the number of students in that particular class. From the first one, when you multiply the width and the height, which is a length in this case, we shall get a height equal to the frequency there, which is 5. So we are having 5 learners or 5 students there. In the next one, it's 9. Remember, we want to add until we get the 20th for the median. So far, we are only having 5 and 9. But when you consider, that's a total of 14. So you're supposed to be very careful. That's a total of 14, right? Now, with 14 there, you ask yourself, how much is accommodated in the third class? It's 8 of them. If these ones are 8, we don't need all of them. We only need to top up 14 so that we may get 20. Therefore, in the third class, we only need 20 minus the 14 that you already have. We only need 6. Yeah, we only need 6 students. So we don't need all the 8. We need 6. If we need 6, this is what you're supposed to do. Let me change the color there so that you may understand what we are doing. I need a vertical line which will represent only 6. So area that is equal to 6, the height is constant, which is 0.8. 0.08. I should multiply it by a certain width so that I get exactly 6. So for me to get x, what am I supposed to do? I divide 6 by 0.08, and that's exactly 75. So I need to add 75 on the last number of students here. So on 299.5, I'm adding 75. 299.5, I'm adding 75. What will I get here is our median value, 299 divided 12.5. This is exactly 374.5. This is now the median value. I'm going to use the median formula to show you that when you use the graph, you're supposed to get the same number. It's good for you to show with a vertical line when 75 is added here. Remember, this up to this point, we'll have added 50. So to add 75, it means you add 60, 70, and because this will be 80, now the vertical line will be at a point here. Therefore, I do a vertical line because the graph is having blue. Let me check that green. So this is where the line will pass through. So on that vertical line is going to give us the median. That's where the median will lie. Now allow me to do this. Calculate median using the formula so that we may see whether we get the same value as the value that we are getting from the graph. So let's check. From the median formula, median is supposed to be given by lower class boundary plus total frequency over 2 minus cumulative frequency before the median class out of frequency of the median class. This is supposed to be multiplied by the class interval, or rather the class width, the class size. Now in our substitution, we have already identified our median class. It's here. 299.5 all the way to 399.5 using the boundaries. So the lower boundary is 299.5. 299.5 plus total frequency 40 over 2 minus cumulative frequency before. When you talk about cumulative frequency before, it means if this is 5, that's another column called CF, cumulative frequencies. So 5 plus 9, we get 14. 14 plus 8, we get 22. So now, because this is our median class, now we consider the cumulative frequency before the median class, which is a 14. So I'm writing 14 at this point. Out of frequency of the median class, frequency of the median class is going to be 8. Then the class width, which is 100. At this point, we're having 299.5 plus 20 minus 14 over 8 multiplied by 100. This is going to be 299.5 plus 20 minus 14 is 6. So 6 times 100 over 8, exactly 75. When you add this, you will just get the same value as what we have obtained from the graph. So I add 75 to 299.5, 374.5. I've just gone to the formula to prove to you that when you use the graph and the formula, the answer for median is supposed to remain the same. You see? So we can check part 2 of Roman C. Part 2, the number of schools with more than 600 learners. The number of schools with more than 600 learners. And remember, we are supposed to use the histogram, more than 600 learners. So 600 learners, that is going to be, according to the class here, more than 600. So we check where 600 is first, according to the, 600 is within this class. So according to the histogram, where are we going to have 600 lying? The value of 600. So we check 600 in this particular graph. 600 will start just after 599.5. That is where 600 will begin. So 600 will begin at this point. 600 will begin there. Now, if 600 begins there, then it means the number of students or the number of schools here and the number of schools here are the ones that are having students that are above 600. So the number of students here for 600, it shall be, I'm now trying to consider from 699.5 all the way to 600. The interval here shall be 99.5. So the interval is 99.5, and the height of this class is here, 0.013. 0.013. So 99.5, I multiply by height. Remember, the height is given by frequency divided by class interval. Therefore, the height here is going to be a frequency of 7 divided by the class interval for this particular class, which is going to be, is it 150 or 200? It's exactly 200. Then we add the number of schools that are in this last class. The number of schools there is going to be 2 of them. So 2 schools there. From the first class, of course, we are going to get an estimation. So by 7 out of 200, I'm getting 3.5. 3.5 plus 2. This is exactly 5.5. Now that we are dealing with the number of schools, then we round this to exactly 6 schools. So it shall be 6 schools which are having 600 students and above. Remember, we are getting an estimation simply because we are picking values from a graph. In case it was a calculation, we would have gotten an exact number of schools. So that is how the histogram is supposed to be approached. Then here comes the number 21, which is telling us that a wholesale shop uses matrices to monitor stock movement. Matrix A, X2, 4, 1, and matrix B, 3, 5, 2, 4. They are used in a computer model. Now determine the value of X for which AB is singular. AB is the product of the 2 matrices. When you are told a matrix is singular, it means that the matrix has no inverse. When it has no inverse, it means it has a determinant of 0. So how do we get determinant of a matrix? But before then, can we check the multiplication of A and B? So to multiply A and B means you write A first, then B, 3, 5, 2, 4. You are not supposed to change that order of the matrices. When you're multiplying matrices, you should know that A times B is not the same as B times A. This is unlike when you're multiplying integers or any other numerical problem, whereby 6 times 3 is the same as 3 times 6. This one is true, it's the same. But when it gets to matrices, you are supposed to order them according to the instructions. Okay, so here we can now perform the multiplication. To multiply matrices, you need this row times this column. So we're talking about x times 3 plus 2 times 2. So this is 3x plus 4. That's one element, 3x plus 4. It's an element like that. Then the same row and the next column, which means x by 5 and 2 by 4. That's 5x and 8. Then we proceed to the next row and the same columns, 4 by 3 and 1 by 2. This is 12 plus 2, giving us 14. Then this is the same row in the next column now, 4 by 5 and 1 by 4. This is 20 and 4, 24. That's now the product of the two matrices. Because the space is not enough, you will allow me to use the space here. Now we've been told that the product of the two matrices is a singular matrix. So this answer matrix is singular. When it is singular, we've said determinant is 0. So the determinant equals to 0. How do we get determinant? Product of the elements in the main diagonal minus product of the elements in the other diagonal. We are now supposed to get a 0. Therefore, 24 multiplied by 3x plus 4. Then we subtract 14 multiplied by 5x plus 8. We are supposed to get a 0. That is what it means by a singular matrix. So through this, we can solve for x. 24 by 3 is 72x. 24 by 4, is it 96? Can you confirm that from your calculators as we continue working? Yeah, 96. Minus 14 by 5, is it 70? Yeah. Then this negative now will affect the value at this point. 14 by 8, which is negative 112. This is equal to 0. Now we can group terms together. 72 minus 70 will give us 2x. 96 minus 112 will give us negative 16. Negative 16. This is equal to 0. Now 2x negative 16 becomes positive on the right-hand side. So to remain with x, we are dividing by 2 both sides. This becomes exactly 8. So the value of x, according to number 21a, is supposed to be exactly 8, like that. A very simple question. You're just supposed to know that when you're told a product of two matrices, or when matrices are written as A, B, that means product of A and B. And when performing the multiplication, then you're not supposed to interchange the two matrices. And when doing so, it's supposed to be row times column, the same row times the next column, so that you may get the subsequent elements in the answer matrix. I hope that is understood. And we proceed to part B. Remember to subscribe to Shifting Grades. Remember also to share so that you may invite your friends to this platform. Part B. During the back-to-school season, a stationery shop sold exercise books and pens. On one day, a customer bought 5 exercise books and 4 pens for 420. Another customer bought 3 exercise books and 6 pence for 270 Kenya shillings. Let X represent the price of one exercise book and Y represent the price of 1 pen. Roman 1, form two equations representing the above information. Remember, the price of an exercise book is X, that of a pen, Y. So let's not confuse the two values. Now, 5 exercise books, and each is costing X, plus 4 pens, and each is costing Y. We get 420. You see that? Then again, 3 exercise books, 3 by X, and 6 pens, each costing Y, 270. Now, these are two linear equations. To save our time for part 2, allow me extract what you call a matrix equation. To extract a matrix equation, you need first to get the coefficients 5, 4, 3, 6. That's called the coefficients matrix. Then X, Y. That is called the variables matrix. Then on the right-hand side, we shall have 420 and 270. This is now called the constants matrix. 3 matrices to give us the matrix equation. Coefficients matrix from the coefficients of the variables, then variables matrix, X and Y, then the constants matrix according to the values on the right-hand side. Part 2, use the matrix method to determine the price of an exercise book and that of a pen. Now, in this case, you're supposed to know that we need the determinant of the coefficients matrix so that we find the inverse. So can we start with the determinant? Determinant is product of elements in the main diagonal. The main diagonal is the one that runs from top left to bottom right. So 5 times 6 minus product of the elements in the other diagonal. The other diagonal is 3 by 4. That's what we are having there. This is 30 minus 12. 30 minus 12 is going to be 38. 30 minus 12 is going to be 18, sorry. 30 minus 12 shall be 18. With the determinant like that, we can proceed to find the inverse. Now, inverse of a matrix is given by, you divide every element by the determinant. So you divide everything by the determinant. That means multiplying by the reciprocal. You exchange the position of the elements in the main diagonal. So 5 and 6 will change positions. 6 will come here, 5 here. Then the elements in the other diagonal will change their signs. If an element is positive, it becomes negative. If it's negative, it becomes positive. So this becomes a negative 4. This becomes a negative 3. This is now the inverse. You can open the brackets or you cannot. It's already good to go. When you open the brackets, it shall be 6 over 18 because we are now multiplying by 1 over 18 to divide by the determinant. 6 over 18 will be a third. Now negative 4 over 18 shall be negative 2 over 9 because I'm dividing by 2, 2 by 2, 9. We remain with the negative there. Then negative 3 shall be negative 1 over 6. Then here it shall be 5 over 18. So you can conclude the multiplication this way, or you still leave it at this point. It should be good. Now, the first thing that you do after getting the inverse is to pre-multiply the matrix equation by the inverse of the coefficients matrix. To pre-multiply means it is this inverse to begin. So we start with a third. Start with the third. Sorry for that. Start with the third. The negative 2 over 9. Negative 1 over 6. This is 5 over 18. Multiplied by 5, 4, 3, 6 times xy equals to, on both sides we are doing the same, third, negative 2 over 9, negative 1 over 6, 5 over 18. This one is now going to multiply 420 and 270. At this point, there are a few things that I want you to remember about matrices. When we multiply a matrix together with its own inverse, we get the identity matrix. So identity matrix is the matrix 1, 0, 1. That's called the identity matrix in XY. So there is no need of performing multiplication at this point. As a math student, you're supposed to recall and apply the fact that a matrix times its own inverse should give us the identity matrix. So without having to multiply, you just write that. Because even when you multiply, you'll still get this inverse times a matrix gives us the identity matrix. Now we perform multiplication on the right-hand side. This row times this column. Let me use my calculator, 1 over 3. That one multiplies for 20. Then negative 2 over 9. That multiplies 270. I'm getting exactly 80. Next should be this row times the same column. Negative 1 over 6. This one multiplies for 20. Positive 5 over 18. This one multiplies 270. I'm getting exactly 5. Yeah, I'm getting exactly 5. Now with this, you're supposed to know again that any matrix multiplied by the identity matrix remains the way it is. So xy just remains xy, 85, meaning that the value of x is 80. The value of y is 5. Remember, the value of x was the cost of an exercise book. The value of y was the cost of a 1 pen. So in this particular shop, the cost of an exercise book is exactly 80 bob. That of a pen, exactly 5. So that is it. Now, can we check number 21C of the same paper? 21C. The students' welfare bought 10 cartons of each. 10 cartons, each of 5 dozens of exercise books and 6 boxes, each containing 20 pence for motivation awards. Determine the total amount of money the welfare spent. Look at this, 10 cartons and each is having 5 dozens. So 10 cartons times 5 dozens, those are 10 dozens. How many items are in a dozen? 12. Those are things that you're supposed to remember. Times 12. So to get the total number of exercise books now, 10 cartons. Each carton is having 5 dozens, and each dozen is containing 12 books inside. So how many books are here? How many books first? 50 times 12, I'm getting 600. So there are 600 exercise books. Are we together there? Then 6 boxes, each containing 20 pens. 6 boxes, and each box has 20 pens. So this is 120 pens. Now, how much is this welfare going to spend? 600 books, and each book is going for 80 bob, plus 120 pens, and each pen is 5. So what will be the total expenditure for this particular school? 600 into 8, 0, plus 120 into 5. I'm getting exactly 48,600 Kenya shillings. Yeah, 600 Kenya shillings. That's number 21. Application of matrices in solving linear equations. A very good question. Now we can also check number 22, which is on area approximation. We're going to use the 2 methods of area approximation, the mid-ordinate rule and also the trapezium rule. So we read the question together. The diagram below is a sketch of the curve y equals to y equals to negative x squared minus 2, and the line y equals to 1. The first question. In the first question, we're being told is using the trapezium rule with 7 strips, estimate the area bounded by the curve, the lines, x equals to negative 4, x equals to 3, and y equals to 1. So look at the area that we are going to estimate. I want to show you the area that's bounded from negative 4 up to the line and also up to where the curve is, all the way to positive 3, and also the other line up there. See that? So this is it now. So at negative 3, it's from negative 4. So we can consider partitioning this one into 4 portions. Partitioning this into 4. From 0, we can have 1, 2, 3. This way. Those are now the areas. Then 3 portions, 1, 2, 3. Now, when we are talking about strips, we mean these areas. 1, 1, 2, 3, 4, 5, 6, 7. Those are 7 strips. The areas there are what we call strips. Then something else, strips, not stripes. Strips. Then look at these lines that are partitioning the areas. The lines that are partitioning the areas, these ones are called ordinates. Those ones are called ordinates. So now we are going to use 7 strips to estimate this area. Now, for us to get the area, one thing that we're supposed to know is that the area is 2 types. There is area below the x-axis and area above the x-axis. Now, from negative 4 all the way to 3, how many units do we have there? 1, 2, 3, 4, 5, 6, 7. 7 units. And we are having vertically 1 unit. So the area here, which I'm going to paint red, the area that I'm going to paint red, the whole of this shall be exactly, not even an estimation, shall be exactly 7 horizontally, 1 vertically, 7 square units. Now, the area below the x-axis is now going to be found using the formula. That one I will use now, the formula. I will use the formula. So allow me come up with the ordinates first. Allow me come up with the ordinates, the values of x and the respective values of y. X, y, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, like that. So let's get the values of y, rather the heights of the ordinates, the height of these ordinates. The curve equation is already known, negative x squared minus 2. So negative 4 squared minus 2. I'm getting negative 18. It's the first value. Then negative, negative 3 is now squared, then minus 2. We get negative 11. Then negative, negative 2 squared minus 2. I get negative 6 with negative 1. shall be negative 1 squared minus 2. I get negative 3. Then with 0, I will get a negative 2. Yeah, with 0, I get a negative 2. Then I proceed to positive 1. With positive 1, it shall be negative 1 squared minus 2. I get negative 3 once again. Negative 2 squared minus 2. I'm getting a negative 6. And at 3 shall be minus 3 squared minus 2. Exactly negative 11. Now, with these values, one thing that you're supposed to know is that you are supposed to substitute absolute values of y. The negatives simply mean these are values of y below the x-axis. But now, for area, which is a measurable quantity, we just interested on the sizes. So instead of negative 18, you just pick 18. Instead of negative 11, you just pick 11. So you're supposed to be considerate enough not to substitute in the formula negative values. Area, according to the trapezium rule, is given by half h. In this case, h is the uniform length of these particular strips into, we talk about the last and the first values of y plus 2 multiplied by the y's in between the last and the first. Look at this. Half multiplied by, it's only 1, the uniform length of the intervals from negative 4 to negative 3 to negative 2 to negative 1 to 0. The interval is just 1. So half times 1. The first value of y is 18. The last one is 11 plus 2 multiplied by the other values now in between. Between 18 and 11, we have 11, we have 6, we have 3, we have 2, we have 3, we have 6. Like that. Half times 1, it remains half. 18 plus 11, 29 plus 11, 6. I'm adding 3 and 2. And I'm also adding 6. So I get 28. 2 into 28. Like that. So this now shall be half into 29 plus 56. 29 plus 56. This is exactly 85. So when you multiply 85 by half, you shall get 42 and half. 42 and half square units. The now total area. You remember very well. Remember very well. What are we remembering? That there was 7 square units because the area should be between the y equals to 0, the intervals negative 4 to 3, and the curve. That's the area we are finding. So we add 7 now to this. We add 742.5 plus 7, get 49.5 square units. 29.5 square units. So that is now the area estimated using what you call the trapezium rule. What about part B, whereby we need to use the mid-ordinate rule, still with 7 strips to estimate the area bounded by the curve, the same lines, and also line y equals to 0. Now, when we talk about mid-ordinate rule, in the mid-ordinate rule, we use the middle heights of every strip. The middle height of every strip. And that is what we are going to find now. X, Y. When you talk about the middle height, you mean the middle height of this strip when X now is between negative 4 and negative 3, which is negative 3.5. So negative 3.5, negative 2.5, negative 1.5, negative 0.5. After 0, we go to 0. We go to 0.5. Then 1.5 and 2.5. 2.5. I hope I've used the correct intervals. Yeah, correct intervals. Look at that. Look at that. The curve is y equals to negative x squared minus 2. So that's where we will be substituting to get the values of y. So we're talking about negative 3.5 squared minus 2. So I'm getting negative 14.25. The negative 2.5 squared minus 2. I'll get negative 8.25. What about with 1.5? Negative 1.5 squared minus 2. I'll get negative 4.25. At 0.5, negative 0.5 squared minus 2. Negative 2.25. Minus 0.5 squared minus 2. I'm getting the same values now. 2.25, negative 4.25, and negative 8.25. Those are the middle heights now. To get the middle heights, I'm using the middle values of x for me to get the middle heights of these curves. Area, according to the mid-ordinate formula, is the uniform height. Then we add all the values of y. All the values of y. All the values of y up to the last one. The uniform height is 1. So again, we use what we call absolute values. 14.25, 8.25, 4.25. After 4.25, 2.25, then another 2.25, then 4.25, and finally 8.25. So we just add and multiply by 1. So 14.25 plus 8.25 plus 4.25 plus 2.25 plus 2.25 again plus 4.25 plus 8.25. I'm getting exactly 43.75. So that now actual area. Okay, total, sorry, not actual, total. Total area shall be, you pick this value, which is below the x-axis, you add the 7 units squared that are above the x-axis. So 50.75 square units. 50.75 square units. A very good question. Very, very good question. That's number 22. Accounting for the area between the x-axis and y equals to 1, knowing that vertically it's 1 unit and horizontally there are 7 units, and that's simply a rectangle, 7 times 1 to get 7 square centimeters. Then now you work the area below the x-axis, covered by the curve and lines x negative 1, x positive 3. That one required a lot of wisdom for you to analyze carefully and work out such a question. Have you subscribed to Shifting Grades Online School? Yeah. Have you shared the link with a friend as we check this transformation in number? 23. Yeah, number 23 now. We read out together. Draw triangle ABC with vertices -1, 4, -3, 3, -2, 1, and its image with vertices -2, -8, 6, -6, and 4, -2 on the grid. So let's check that first. Plotting, -1, 4, -1, 4 should be here. That's our A. -3, +3. That's our B. -2, 1. -2, 1. That's our C. So can we join to come up with this particular triangle and get this particular triangle? It's a good one. A good triangle. Then the image is now -2, 8. No, +2, -8. That's A prime. What about B? 6, -6. 6, -6. B prime. What about C? 4, -2. 4, -2. Outrightly, this is likely to be an enlargement. This one is likely to be an enlargement. But let's draw and see. Let's draw and see. No? This one has been enlarged. This one has been enlarged. Anyway, to understand the enlargement, if it is so, we're supposed to join a point and its image. If it's A, we join A and A prime. So can we join that? If it's C, we join C to C prime. All right, this is an enlargement. And can we understand the enlargement more? Because we are told to describe fully the transformation that maps A, B, C to A prime, B prime, C prime. So it's an enlargement. Center, where the lines are meeting its center, origin, 0, 0. So center, 0, 0. See that? Center, 0, 0. Then with the center 0, 0 now, the scale factor is something else that should be understood now. Scale factor. One thing that you're supposed to observe is that from the center of the enlargement, which is the origin, from the center of the enlargement, C and C prime are on opposite sides. A and A prime are on opposite sides. So it's a negative scale factor. So scale factor is negative. Now we check it's negative what? The number of times a coordinate is moved to the other side. From center to C, that's the distance. How many times on the opposite side? 1, 2. 2 times. Is it the same for A? The distance is here to the center. So 1, 2 times again. So a point is being moved 2 times, but on the opposite side of the center. Opposite sides gives us the negative, and moving 2 times gives us 2. So it's a scale factor -2. Are we together up to that point? A good one. Describing fully an enlargement. Describing fully an enlargement. Very good question. Very, very good question. Now with that, we check part C of the same. In part C, we're being told this, that on the same grid, draw the second image of the first one after reflection in the line y equals to 0. Line y equals to 0 means the x-axis. So we reflect along the x-axis. To reflect means you join a point to the mirror line, which is the x-axis. Y equals to 0 is the x-axis. So if it's C, you join it. Then you move an equal distance to the opposite side, meaning that C prime, double prime shall be there. You do the same for B. Yeah, you do the same for B. You join B. Then you move an equal distance. of an equal distance. So how many units are these? 6 units. So we're moving 6 units to get B double prime. And for A, 8 units. You join 8 units below. After the mirror line, you move 8 units above. 8 units above. So this is where A double prime shall be. And with that, now they can be connected. You can now connect like that. Like that. If they want the coordinates, we can read for them. If they want, you can extract coordinates for them. But that's basically how you reflect from this point to that point. After that, we check another part, which is now part D. Part D. In part D, we told that A double prime, no, triple prime, is the image of A double prime after reflection along a mirror line M. Draw the triangle and hence state the equation of the mirror line. So coordinates of A is provided -8, -2, -8, -2. -8, -2 shall be here. That's where A triple prime is. Did I read well? Yeah, -8, -2. That's where A is. That means now, that means A is being connected. A is being connected to a certain, we use yellow. A is being connected to a mirror line. Then we proceed to the other side. Like that. So we need to identify the midpoint of A, which is 8, 2, and the other image, which is -8, -2. When you add this, you're getting a 0/2, which is 0. You add this, you get a 0. So coordinate 0, 0 is the midpoint. Is that really true? We are adding 8 and -8, and you divide by 2. I get 0. Again, I'm adding 2 and -2, and I divide by 2, I get 0. So the midpoint of A and its image is coordinate 0, 0. And the line is not even passing through 0, 0. So I wanted to identify that midpoint by calculation. 8, -8, 2. 8, 2. Then I divide by 2. Just a minute. I'm confirming that midpoint. Anyway, we can check the number of units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 units. 1, 2, 3, 4, 5. Yeah, 5 will be at point B. At point B. So at point B, and will be very perpendicular. At point B, and will be very perpendicular. I'm trying to check a conspicuous color that has not yet been used. And will be very perpendicular. We'll get our mirror line. So that is now the mirror line. This is now the mirror line. You identify the midpoints of the coordinate and its image. Yeah, the mirror line of the coordinate and its midpoint. With the mirror line like that, we can now connect the other points and get their images. If it's B, you connect it to the, like that. How many units are these? 1, 2, 3, 4, 5, 6. Then we move again 6 units. 1, 2, 3, 4, 5, 6. So we're moving up to this point. to get our B prime third image. For C, we do the same. C to the mirror line, and it should be perpendicular. Then we are moving 1, 2, 3 units. So 3 units, 1, 2, 3. 3 units. So this is our C triple prime. So now the drawing can be obtained. A to B and to C. A to B and to C. A to B and to C. Like that. You see, now we have reflected again. We have done another reflection. Now from that, I think the mirror line now is clear. Mirror line M, that one is clear. When X is -4, Y is 4. -5, +5 along that line. Therefore, this is mirror line Y equals to the negative value of X. It's a known mirror line. You just needed to identify it. Yeah. We have done it by construction, but I didn't know why. I didn't understand why we could not get the midpoint of A and A prime. The reason we couldn't get that midpoint is still not adding up well. 8, 2, and -8, -2. The sum of 8 and this will get a 0. The sum of the y's, it will also become a 0. So I don't know why by calculation it was not obtained. But even if we didn't get it by calculation, we've done it geometrically such that we divided A to A prime at the middle so that we get the mirror line where this point has to be connected. Then we proceed to the other one. I think that's okay. I think that one is okay. So we are good now to proceed. We are good to proceed. In part C, state the type of congruency between the second and the third image. Directly, this is going to be opposite congruence. Opposite congruence, or rather indirect congruence. Indirect congruence. Simply because it is a reflection that has been involved. Indirect congruence. Indirect congruence. This one is brought about by reflection. So if it's a reflection involved, if it is a reflection that has been involved, what do we expect? Indirect congruence. Then if what has been performed is a rotation or a translation, then we expect a direct congruence. Direct congruence comes from rotation and translation. Yeah. Rotation and translation. Rotation and translation. That is what you are supposed to know. When you know that, you will never struggle to identify a pair for a certain type of congruence or the type of congruence involved in a certain pair. It is the rotation or the translation that is going to give us a direct congruence. It is the reflection which is supposed to give us indirect congruence. Indirect congruence. Are we together up to that point? Are we together up to that point? If yes, type yes, we are together. Then we check the very last question now. Number 24. Yeah, number 24. In number 24, we've been told that a particle moves such that its displacement s meters from a given point is given by Displacement S equals to 2/3 t power 3 plus 3 over 2 t squared minus 9t plus 5, where t is time in seconds. Find the displacement of the particle at t equals to 3. So this is direct substitution now, whereby displacement is given by 2/3 t equals to 3 power 3 plus 3 over 2 times 3 squared minus 9 into 3 plus 5. Direct substitution. Then you compute this. 2 out of 3 into 3 cubed plus 3 over 2 into 3 squared minus 9 into 3 plus 5. The displacement shall be negative 40 and half meters. Negative 40 and half meters. I hope the computation has properly been done. I hope that one was so proper. I hope that one was very proper. We have to confirm that. 2/3 into 3 cubed plus 3 over 2 into 3 squared minus 9 into 3, then plus 5. I'm getting 9.5. I think that's an error. 9.5 meters. So we have the distance. After that, can we talk about part B of the question, where we told to find the value of t when the particle is momentarily at rest. Momentarily at rest means velocity becoming 0. Momentarily at rest. Now, can we talk about velocity function being given by differentiating displacement with respect to time? So to differentiate this this particular function, it means the power of 3 to multiply the function. 2/3 by 3, it becomes 2. Then t now becomes squared. 2 here to multiply again. So 3 over 2 by 2, it becomes 3. And t now is to power 1. Negative 9t, t is to power 1. So 1 times negative 9, we get negative 9. And t becomes power 0, which is equivalent to 1. So it disappears. 5 is also going to disappear during differentiation. Now, 2t squared plus 3t minus 9 equals to 0 is the equation that we are solving quadratically to find the values of t when velocity equals to 0. When velocity equals to 0. So with this, now we need to talk about the value of t being given by negative b plus or minus the square root of b squared, which is 3 squared minus 4a times c, which is a negative 9. I'm using the quadratic formula out of 2 by the value of a, which is also a 2. This shall be negative 3 plus or minus. I now get to my calculator to compute this thing. 3 squared is 9. So we add, because negative 4 and negative 9 at that point, negative 4 times negative 9 automatically changes to positive. So plus, I open brackets for 4 and 2 and 9. This is going to be 81. So when I take square root, I'm getting exactly 9. Exactly 9 out of 4. So the values of t shall be negative 3 plus 9 over 4, or negative 3 minus 9 over 4. Negative 3 plus 9, then we divide by 4, I'm getting 1.5, or t equals to negative 12 over 4, which is negative 3. So the values of time shall be 1.5. 1.5 like that. Exactly 1.5. So that is the value of t, because we can't have negative time. of all the quantities that you can have negative. Anyway, time is a scalar quantity. You know, if time was to be picked as a negative, then we would maybe imply that time is a scalar quantity and negative can mean the direction. But now in this case, it's just a scalar quantity, so it can't have a negative. It cannot have a negative. So we stick to the positive value of time. Then now, we have in part C. Can we check part C? In part C, we're told to find the displacement during the 4th second. Mark that, during the 4th second. So during the 4th second, we need displacement at 5 minus displacement at 4. What had been covered up to 4 and what will be covered up to 5? When you subtract, you'll get during the 4th second, during the 4th second. So at t equals to 4 minus at t equals to 3. So displacement at t equals to 4, because we have at t equals to 3 already. So 2/3 into 4 power 3 plus 3 over 2 into 4 squared minus 9 into 4, is it plus 5? Minus 9 into 4 plus 5, yeah, that way. What will be this value? 2/3 into 4 power 3, then we add 3 over 2 into 4 squared, then we minus 9 into 4, then we add 5. The distance is 35 and 2/3 meters. I hope that is properly computed. Now, if that is well calculated, you see, when distance is 4, when time is 4 units, we have the distance. When it was 3, we also have the distance. So during the 4th, it shall be 35 and 2 over 3 minus 9.5 minus 9.5. This is going to be 26 and a sixth meters. 26 and a sixth meters. That is now during the, because we have distance from t equals to 0 up to t equals to 3. Then again, distance from t equals to 0 up to t equals to 4. So why can't we work out during the 4th seconds? During the 4th second. So it will just be the difference. Simply the difference. So that's how you're supposed to approach and see. That's a good question. Very, very good question. Part D of this last question. The particle's initial acceleration. Initial acceleration means acceleration at time equals to 0. That is the initial acceleration. Then acceleration is computed by differentiating velocity with respect to time. Can we differentiate velocity, ladies and gentlemen? Can we differentiate velocity? Can we differentiate velocity? Can we differentiate velocity? Check it out together. We have velocity function here. So to differentiate it means the power of 2 should multiply the constant. Yes, so 4t power 1. 4t, in other words. 4t plus. This is a 3t, so it's power 1. 1 times 3, we get 3, and t becomes power 0. So plus 3, simple like that. So acceleration, initial acceleration will be 4, time equals to 0, plus 3 meters per second squared. That is now the initial acceleration. of this particular particle? A good question, ladies and gentlemen. Thank you so much for following. Please be reminded of our consultation line 0704 15 33 66. Teacher Boniface in charge of Shifting Grades Online School. That was a powerful session. We are done. We are done. Thank you so much. See you next time. See you in our programs every Sunday, Form for Mathematics, every Friday, KGCSE Integrated Science, every Wednesday, KGCSE Mathematics Preparations. Use our number, which is on the board, 0704 15 3366 to consult us about the classes. Remember to enroll for the holiday classes also. This is for the continuing student. See you in the next presentation. Bye-bye.